Right now, beneath the waves, there's a world that defies everything you thought you knew about life on Earth. A place where the rules of survival are completely rewritten, where creatures glow in the dark, turn themselves invisible, or grow to monstrous sizes for reasons we still can't explain. We've sent rovers to Mars. We've photographed distant galaxies billions of light years away. But the ocean? We've barely scratched the surface. Less than 5% explored. Think about that. You know more about the craters on the moon than what's happening right now, 6,000 feet below the water you swim in. Today, we're going deeper than most humans will ever go. Past the light, past the familiar, into a realm that seems like science fiction, but it's as real as the ground beneath your feet. This is the story of the deep sea. Let's start at the surface. Bright, warm, teeming with life. Sunlight powers everything here. Plankton blooms feed fish, fish feed whales, and the whole ocean hums with energy. But now we're descending, 200 meters down. Watch what happens. The light, it's fading, fast. Welcome to the Twilight Zone. A massive layer of ocean stretching down a full kilometer. The sun's rays? Too weak to do anything useful. Photosynthesis stops. The forests of plankton disappear. No plants, no green energy whatsoever. So what do animals eat down here? Snow. Not the kind you're thinking of. Marine snow. Tiny fragments of dead plankton, bits of waste, the remains of creatures from above, all slowly drifting down like an underwater blizzard. To you and me, it looks like nothing. To the animals here, it's everything. And the creatures that have evolved to survive on this? They're bizarre. Take the glass squid. Its entire body is transparent. You can see right through it, organs floating in empty space like a living X-ray. Or the glass octopus, almost completely invisible except for its eyes, two dark spheres floating in the gloom. Why? Why would so many animals evolve to be see-through? Honestly, we're not completely sure. It might be camouflage, a way to vanish in the faint light, or maybe it's about energy. Every bit of pigment costs calories, and down here, calories are precious. But some creatures take the opposite approach. Instead of going invisible, they make their own light. Bioluminescence. Chemical reactions inside their bodies that produce a glow. And it's everywhere down here. Flashing dots, glowing patterns, entire bodies lighting up like underwater fireworks. But this isn't for show. Light is survival. Some use it to hunt. Some use it to find mates in the endless dark. And some use it in the most clever way possible, to disappear. It's called counter-illumination. Here's how it works. If you're a predator looking up, you can spot prey as dark shadows against the faint light from the surface. So animals like the firefly squid cover their bellies with tiny light-producing organs. They adjust the brightness to perfectly match the glow from above, erasing their silhouette completely. They're using light to become invisible. Then there's the bloody belly comb jelly. It glows deep red. But here's the thing, red light doesn't penetrate this deep. So to everything else, this jelly looks completely black. And when it eats something that glows, that light gets trapped inside its red stomach, hidden from predators. It's like wearing night vision goggles in a world where everyone else is blind to infrared. But the Twilight Zone has one more secret, something so massive it stayed hidden until World War II. Every single night, as darkness falls on the surface, something incredible happens. Billions of creatures, lanternfish, squid, jellyfish, rise from the depths. An entire army climbing toward the surface under cover of darkness to feed on plankton. Then, at dawn, they sink back down, vanishing. This is the diel vertical migration, the largest mass movement of animals on Earth. Bigger than wildebeest herds, bigger than locust swarms, bigger than anything. During World War II, naval sonar operators kept detecting something strange. a mysterious layer on their screens that rose every night and sank every morning. They thought it was a false seabed, some kind of equipment malfunction. It wasn't. It was life, an invisible world moving as one, in a rhythm older than civilization itself. Past 1 kilometer, the last traces of sunlight die. We've entered the midnight zone. 4,000 meters of permanent darkness. Temperatures barely above freezing. Pressure hundreds of times greater than at the surface. To us, this seems impossible. A place where nothing should survive. But evolution? Evolution gets creative down here. Meet the dragonfish. Unlike most deep-sea creatures, it produces red bioluminescence. And remember, red light is invisible to most animals down here. So the dragonfish has basically created its own private spotlight. It can see its prey, but the prey can't see the light that's illuminating them. It's like hunting with infrared goggles in total darkness. Other predators have evolved a different strategy. Some fish are covered in ultra-black skin, so dark that it absorbs over 99.5% of light. When a submarine spotlight hits them directly, they almost disappear. They've turned themselves into living black holes. And then there's the anglerfish. You've probably seen pictures. That terrifying mouth, those needle-like teeth, that glowing lure dangling in front of its face, drawing in prey like moths to a flame. But the real horror? How they reproduce. Male anglerfish are born tiny and weak. Their entire purpose is to find a female in the vast, dark ocean, a nearly impossible task. When a male finally finds one, he doesn't just mate with her. He bites into her body and fuses. His organs slowly dissolve, his body withers away until he's nothing but a sack of reproductive cells, permanently attached to her, living off her blood. It's one of the most extreme examples of sexual adaptation in the entire animal kingdom. Not everything here is a predator, though. Some are scavengers, waiting for food to fall from above. When a whale dies and sinks to these depths, it becomes an oasis, a jackpot. Entire communities feed on a single carcass for decades. And yet, even with our submarines and ROVs, we've barely scratched the surface of what lives here. For every species we've documented, scientists believe there are dozens more we've never seen. Each dive brings back something new. Glowing eyes, bodies so fragile they disintegrate when brought to the surface, adaptations that rewrite our understanding of biology. 4 kilometers down, we finally touch bottom. This is the abyssal plain, one of the largest habitats on Earth, covering more than half the planet's surface. And it's basically a desert. No coral reefs, no kelp forests, no landmarks of any kind. Just endless mud stretching for thousands of kilometers in every direction. Temperature locked at 4 degrees Celsius. Food almost non-existent. And yet, life finds a way. One of the strangest adaptations? Size. Many creatures down here are giants compared to their shallow water cousins. Giant isopods the size of small dogs scuttle across the sediment. Amphipods, normally tiny shrimp-like creatures, can grow longer than your hand. The colossal squid, one of the largest invertebrates alive, prowls these depths. Scientists call it deep-sea gigantism. But why does it happen? We honestly don't know. Maybe it conserves energy. Maybe it's defense. The truth is, it's still a mystery. Food down here is rare, but when it arrives, it's a feast. When a dead whale sinks to the bottom, it's like winning the lottery. Within hours, scavengers swarm it. Hagfish, sharks, amphipods tearing away chunks of flesh. Then stranger creatures move in. Bone-eating worms that burrow into the skeleton, feeding on oils trapped inside the bones for decades. One carcass can sustain an entire ecosystem for years. Other animals survive on less. The vampire squid, despite its terrifying name, isn't even a predator. It collects drifting particles of marine snow using long, sticky filaments. In this oxygen-starved environment, it survives using blood with the highest oxygen-carrying capacity of any known cephalopod. Life here is slow. Creatures grow slowly, reproduce rarely, live for centuries. The Greenland shark can live over 400 years, the longest lifespan of any vertebrate we know of. Time itself moves differently down here. And even in what looks like empty mud, life persists. Every grain of sediment is packed with microbes, recycling nutrients, sustaining hidden food webs we're only beginning to understand.
Beyond the plains lie the trenches, the deepest scars on Earth. This is the Hadal Zone, named after Hades, the underworld. It stretches from 6,000 meters down to nearly 11,000, the deepest point on our planet. If you dropped Mount Everest into the Mariana Trench, its peak would still be over a mile underwater. Think about that. Pressure here exceeds 1,000 times what we feel at the surface. To a human body, it would be instantly fatal. And yet, life thrives. One of the most astonishing creatures? The snailfish. Fragile, gelatinous, with translucent skin that looks like it would tear at the slightest touch. It seems impossible that something so delicate could survive here. But these are the deepest living fish ever discovered. Their bodies lack rigid bones. Their cells are reinforced with special molecules that keep their proteins functioning under crushing pressure. They've evolved to thrive where nothing else can. Other creatures swarm the trench floor, amphipods by the thousands. And here's something disturbing. Recent studies found plastic fibers inside their bodies, even here, in the most remote place on Earth. Human pollution has arrived. Along the trench walls, life takes an even stranger turn. Hydrothermal vents spew superheated water laced with chemicals from Earth's crust, hydrogen sulfide, methane, dissolved metals. And microbes feed on this. Not sunlight, not marine snow, pure chemistry. Entire ecosystems of worms, clams, and crabs depend on these microbes. A food web powered not by photosynthesis, but by the planet itself. And this raises a mind-bending question. If life can exist in these conditions on Earth, could it exist on other worlds? Icy moons like Europa and Enceladus have oceans beneath frozen crusts, warmed by internal heat. The Hadal Zone might be our closest glimpse at what alien life could look like. And yet, we know almost nothing. Fewer people have visited the Mariana Trench than have walked on the moon. Each dive brings back creatures unknown to science. Translucent sea cucumbers, gelatinous blobs with no clear anatomy, microbes whose biology we can't explain. For all we've discovered, the deep sea remains a world of questions. More than 80% of the ocean is still unexplored. Every expedition brings back something that shouldn't exist. Transparent fish, glowing worms, creatures that break every rule we thought we knew. Why do so many animals grow to giant sizes? Why do others turn invisible or cloak themselves in darkness? How did 3/4 of deep-sea life evolve the ability to produce light? And why in colors that nothing else can even see? We don't have answers. And maybe that's the point. These mysteries remind us that Earth still holds secrets. Vast, beautiful, terrifying secrets. A frontier closer than Mars, stranger than anything science fiction has imagined. And it's right here, beneath the waves, waiting.